Hello, this is 8.4, solving absolute value inequalities. I can solve absolute value inequalities graphically and algebraically. So first, to solve it graphically, we will start out by graphing each side as a separate function, just like we did in 8.3 rather. Okay, so first for this one, our vertex will be -3, 1, and our slope, since there's nothing there, will be just 1. So m equals 1 over 1. So we have -3, 1, up 1 over 1, up 1 over 1, up 1 over 1, 1 over 1, over 1. Okay. I'll try to draw a relatively straight line. Okay. And then we'll graph. So we graph the left side of this inequality, now we'll graph the other. So g of x equals 4. And when we do that, notice our intersection points at x equals 0 and x equals -6. So now what we want to do is look for where the absolute value expression is above, or the graph of the absolute value is above the horizontal line. So it's above it here and here, because that's where this absolute value, the values are above. So that is where x is less than -6, or, because they're not connected, x is greater than 0. And on a number line, you have x is greater than 0, x is less than -6. Again, they don't meet in the middle, they're not connected, so it's an or. Pause the video and try this one, and come on back and check. Okay, so first, we graph the left and the right side of this as separate functions. So this one will have a vertex of 2, -3, and again there's nothing out in front, so the slope will be 1 over 1 again. And then the other one will be g of x equals 1. So 2, -3, up 1 over 1, up 1 over 1. As far as you need to do to make a relatively straight line. Not always that great at drawing straight lines myself. And then 1 will just end up right there. Then the intersection points are at x equals 6 and x equals -2. We want to look at where the absolute value graph, that v is underneath the horizontal line. So it's underneath right in here. So that'll be where x is greater than -2 and x is less than 6. And it's an and because it's connected. And also if you put it on here, on this number line, we have a 6, we have a -2, greater than, less than, they will connect. Now when we solve algebraically, first we will divide by 3 on both sides. We'll have the absolute value of x minus 7 is greater than or equal to 3. So we split it just like we did with equations, with the difference here. So our first one is x minus 7 is greater than or equal to 3. Now we have x minus 7, and we know we want this to be a -3, but whenever you create a negative, you'll have to multiply or divide by -1, which flips the sign. So then our greater than or equal to will change to less than or equal to, and this pattern will work every time. So if we solve this side, plus 7, x is greater than or equal to 10. Plus 7 over here, plus 7 over here, x is less than or equal to 4. So and or, if you can tell already, great, otherwise graph it down here. So x is less than or equal to 4 is going to go that way. X is greater than or equal to 10 will go this way. They're not connected, they don't meet, so it's an or. This next one, it's already, the absolute value expression is already isolated, so that's great. So we'll split it. 2x plus 3 is less than 5, or 2x plus 3, flip the sign and make it a -5. So solving, 2x is less than 2, divide by 2, x is less than 1, -3, -3, 2x is greater than 8, divide by 2, x is greater than 4. Note we did not change the signs in here because we divided by a positive. It's only when you divide by a negative number that you switch the signs here. So to figure out if it's an and or an or, we have x is, I apologize, it's just being -8 and a -4. we still only divided by a positive, so our sign didn't change. So we have x is less than 1, x is greater than negative 4. They meet in the middle. So we have an and. So now we have some real-world examples. So if we have a machine that cuts boards that are 3.25 meters long, it's acceptable for the length to differ by at most 0.02 meters. We're writing an absolute value inequality. So we know that we use L for length, cursive L. The actual length, the difference of the actual length and the 3.25, which is our goal, the absolute value of that has to be less than or equal to 0.02. And if we split this, L minus 3.25 is less than or equal to 0.02. And L minus 3.25, flip the sign, greater than or equal to, and make this negative 0.02. If we add 3.25 to both sides, we end up with L is less than or equal to 3.23. 3.27 rather. On the other side, we add 3.25, and L is greater than or equal to 3.23. To see from here whether it's and or, if you can picture it, great. If not, we'll make a little number line. There's our 3.27. There's our 3.23. So less than or equal to the 3.27, greater than or equal to 3.23, meets in the middle. So it's an and. Please pause and try the next one and come on back. So for this one, if we use weight, we have W minus 13.8, which is our goal, the difference there, less than or equal to 0.1. And if we split it, W minus 13.8, less than or equal to 0.1, W minus 13.8, flip the sign and make it negative, greater than or equal to negative 0.1. If we solve this, add 13.8, W is less than or equal to 13.9, add 13.8, W is greater than or equal to 13.7. This ends up very similar to the above in that they meet in the middle. So 13.9, 13.7, less than or equal to, greater than or equal to, so it's an and. So the ones down here, solving graphically and algebraically, what you should end up with as a solution, these are ones I think you should do on your own, what you should end up with as a solution is x is less than or equal to 4, and x is greater than or equal to negative 2. And check the notes online if you're not sure how we got that. And for the next one, you should end up with x is greater than 4, or x is less than negative 5. Thanks a lot. That's it.